Hi everybody, welcome to the SETI Institute in Mountain View, California, where we study life in the universe, how it came about, how the universe operates as a place where it can flourish, and where we might find it, and where we explain and share what we learn. My name is Matt Tiscareno, and I'm one of the scientists here at the Institute, and today we are talking about where we might find life, but it's actually thinking about ourselves, going to other worlds, specifically the Moon and Mars, of course someday hopefully beyond. My guest today is Pascal Lee, who has been one of the scientists here at the Institute for quite a long time, you were just telling me.
Yeah, I started here in 2000, so it's been almost 20 years.
So one of the institutions that we're very proud of here, and so welcome Pascal, thanks for being with us. The first thing that we want to talk about is in the news. The National Space Council had a meeting recently and came up with a new policy about humans in space. Why don't you tell us your views on that?
Yes, this is big in the sense that NASA has a new formal directive, which is to get humans back to the Moon by 2024, and specifically to the South Pole of the Moon. And so this is a very specific mandate, and NASA, of course, is gearing up to sort of make this happen. Of course, there's still some hurdles. There are some budget approvals and things like that need to happen, but to me this is an exciting opportunity because going beyond low Earth orbit, I mean, first of all, I've been working on trying to get humans to Mars for pretty much all my life, but the Moon is an exciting place. It's a very interesting place, and at this point I think it's a very good and critical step here in allowing us to do Mars properly, and in some sense faster if we go back to the Moon first.
People have this problem.
So, so from my perspective, this going back to the Moon thing is a very exciting new opportunity, and there's going to be lots of new science to be done on the surface of the Moon. And the fact that we're actually not just going into lunar orbit, but actually targeting the surface is particularly exciting because there's lots to see on the Moon, and I've been particularly intrigued by these lava tubes. I should call them more specifically these pits and crater pits that you see at the surface of the Moon, most of which probably are the reflection of a subterranean lava tube underneath. So in other words, a long cavern that runs along the surface of the Moon that in this particular location is collapsed, and so you see the interior of the cavern. But you can imagine sort of a cave system sometimes underneath the surface here in places like so these types of pits, we know of approximately 300 or so of them at this point, even more than that. The vast majority of them are at relatively low latitudes, between the equator and about 50 degrees north. And this bias, if you will, or this concentration of these things at lower latitudes is an observation bias. We run software, the folks at the Arizona State University run software to automate the detection of these pits in images from the Lunar Reconnaissance Orbiter, and it's actually a very clever process. They look at how the shadow and the lit area on the floor at the bottom of the pit moves across the bottom over time as the sun moves across the lunar sky, and you can map out the locations of these pits.
So let's back up a minute and orient ourselves to what is being shown here in this image. So this is an image of the Moon?
This is an example, yes, so of course. This is the surface of the Moon. This is a high-resolution image of the surface of the Moon.
Taken by, do you know?
By the Lunar Reconnaissance.
By LRO?
And
okay.
What you're seeing is a pit that's approximately 80 meters across.
So this big one is only 80 meters. So all of these, what look like craters here, this is the great thing about geology, is that you can't tell the scale just by looking at the image. I mean, I could have believed you if you told me these craters reach a kilometer across.
Poke marks in the background are impact craters. This thing is not an impact crater. In fact, it has the shape of a funnel. If you were to approach it walking on the surface of the Moon, you wouldn't see really a raised rim like you would around an impact crater. You would just start descending and then the next thing you know, you would get to the edge of a pit.
So it's like a sinkhole almost, like, or at least that would be your experience of it. It might have a different
physically
cause.
It's like a sinkhole. Geologically, of course, it's
not limestone, but
yeah.
So so this looks like the floor of it has been offset, or is that just the
lighting?
lighting?
That's just the lighting of the sun. The lighting of the sun. The sun
coming
here
from
is,
over here.
That's right. It's to your right there.
So we're looking down into the
Into
blackness,
the
to the unlit part, and then the lit part is just off to the side.
Right. Exactly.
Wow, I did not know that we had seen.
Yeah. So these are
detail.
really remarkable, and the first such pit was discovered by the Kaguya Japanese orbiter team, but many more were mapped out by Mark Robinson and Robin Wagner at Arizona State University. But like I said, the software that they use to detect these automatically has found that most of these are recognizable only between 50 degrees north and south or so.
Does that have to do with the lighting, or do you think they don't actually exist?
It just has to do with the lighting. That's an observation bias. Exactly.
So they could be in the polar regions, they're just harder to see.
That's right. And so what I endeavored to do last year was to search for these guys in the polar regions. And of course you have to do this manually of the moon, because you have to do this manually. And I think the reason, well, first of all, there's no particular reason why you wouldn't find them beyond 50 degrees north all the way to the pole. It's not that at the poles there would be some special thing going on either. But to me, they were interesting to find at the pole because if you have a cave at the pole, then all of a sudden you might have an environment that is really extremely cold at the surface of the moon, in addition to the permanently shadowed regions of the poles themselves.
Right.
We are super interested for science, but also for human exploration in the polar regions of the moon, the North Pole and the South Pole, because there are these so-called permanently shadowed regions,
that's right.
PSRs. And these permanently shadowed regions never see the light of day. And because they are in the permanent shadow of mountains and crater rims at the poles of the moon, these areas that are in perpetual darkness are extremely cold. And they're so cold that they are associated, sure enough, with some water ice. We now know that there is water ice at the poles of the moon.
Yes.
Both the North Pole and South Pole. And that's very exciting scientifically. That's exciting for exploration. But might there be places that are not at the poles or not quite at the poles where you might also have conditions that would be cold enough for you to cold trap ice? And so a cave that is in perpetual darkness would be such a place.
So, and could accommodate enormously more water than. Okay, I want to talk
I'm
more
glad
about.
you're saying that, because when I say it, I sound like I'm selling this thing, but you're absolutely right. That's exactly it.
Okay, I want to get to that, but first let's get into more detail about how exactly these caves form and how it is that these. Would we correct to call it like a window or a skylight onto the cave happens? So what kinds of caves are these?
So let me get to that in a second.
Okay.
And I will just show you how the process we went through to find some of these near the North Pole of the Moon. And I guess this again was announced just last year. This is just an introduction to what I'm going to talk about today. So I've been looking for some of these pits near the North Pole of the Moon and near the South Pole. And the highest latitude ones, the ones closest to either pole, I found in this particular impact crater that you see here. So this is the moon, of course. This is at the top here showing the north polar region of the moon. There's a large crater that you can see to the off to the left a little bit near the top, which is crater Philolaus. You can see it from the Earth.
It might be good to use the cursor
Oh,
of
yeah,
the
well,
computer.
why don't I
Right?
just
Are
do
we
that?
sharing the screen for this?
We can. Okay. So this is Philolaus crater. Philolaus, named after the Greek philosopher who was the first to propose this heretic idea that we might not be at the center of the universe. So I like Philolaus quite a bit. Philolaus crater is 70 kilometers across, okay, and it's a relatively young, in other words, 1 billion years or less, impact structure on the moon. Okay. And if you look at Philolaus, there's a patch of flat stuff here in the northeastern part of it. That's a sheet of once molten, melted rock. Okay? And the rock was melted not because of volcanism in this case, but because of the sheer heat that the impact dumped into the moon. And so it not only excavated a giant hole and created the crater that you see here, but it melted large amounts of the rocks.
So there was very briefly a lava lake in the crater just from the heat of the impact.
Exactly. And so this is an example, and you use the word lava because precisely that's exactly what it is. It's molten rock. Now on Earth, the lava that we're familiar with is lava from volcanoes. But on the moon, there are volcanoes, and so there are volcanic lavas as well, but there are also impact melt.
Impact melt is perhaps more technically correct.
And there are actually impact melt lavas on the Earth as well, and you find these at large meteorite impact craters on the Earth. For example, at Manicourt crater in Quebec. Okay, it's a large impact crater. So anyway, zooming down onto the impact melt pond, if you will, inside Phil-Lau's crater. So I'm going to show you a successive series of pictures. You start seeing these.
We're zooming in.
You start seeing these sinuous grooves along the floor of the crater. You see these guys running across the floor of the crater. If you zoom into this area, this is what you see. Okay, and you notice that some of these things look like channels, essentially, at this point. But others look like discontinuous chains of pits or depressions, okay, like this here. So what these are, and this is now you entering the realm of geologic interpretation. We don't know this for 100% sure. This is an interpretation of the landscape. Is that what you see here is an uncollapsed or only a partially collapsed lava tube, whereas along here what you're seeing is a fully collapsed lava tube. So let's go into what a lava tube is.
Yes.
On Earth, we're very familiar with lava tubes. When you have a volcanic lava flow down the hill of a volcano, for example.
Right.
The surface of the lava flow tends to cool off relatively quickly because it's in direct contact with the atmosphere, and so it can shed its heat by radiating off the heat from the lava flow and convecting it into the atmosphere as well. Underneath this solidifying upper layer of the lava flow,
basically.
Underneath this, the lava can still be much hotter and molten and continue to flow.
Right.
You can end up in this situation where the top surface of the lava flow becomes rigid because it has cooled off enough. Meanwhile, the lava underneath is still streaming downhill from whatever source the lava is coming out of uphill. And in some cases, the uphill source turns off, and the lava might drain out entirely from underneath the solidified lava crust.
Mm-hmm.
In that case, you end up with a tunnel, essentially. A tunnel that has a solid roof above it. That's the solidified former surface of the lava flow. And this tunnel is where there was once still flowing lava, and now the lava's gone. It's all just drained away downhill. So this is how a typical lava tube forms on Earth. You end up with a winding, subway tunnel, so to speak, that usually goes downhill generally, but it winds down the hillside of a volcano that is covered by rigid lava. So usually you don't see them, except when they start getting old and weathered, they start collapsing, and sometimes they start collapsing with little pits first. In other words, just a very small section collapses, and that's what you call a skylight, when a little beam of light can actually enter the cave just because now the roof has a little hole in it. So that's, in this case, we're looking at the moon, and in this particular instance, this is not volcanic lava, this is impact lava.
Yeah.
So how might this form? Well,
and can I ask a question about that? Oh, maybe you're getting, maybe you're about to answer my question.
Here's an interpretation of how this forms. You have here a profile, if you will, of half of the diameter, in other words, of the radius of the impact crater. So this is what's in gray down here is the impact crater with the raised rim. Okay. Immediately after the impact, in phase one, all of this is molten. All of this should be orange. Okay. All of this should be orange. But then eventually, the top layer of this melted material cools off and becomes rigid.
Yes.
But it can crack here and there, it can split open, and allow lava to ooze up towards the surface. And this lava then flows at this point just like a volcanic lava flow. And it oozes up to the surface because this crust that becomes cooler and more dense pushes down onto this impact melt that is less dense. And the magma rises to the surface,
Okay.
flows, and you have exactly the situation of a classical volcanic lava flow in that lava tube formation process then. So the lava flows, it eats and burns its way into the top part of the crust. Eventually, the top part of the lava flow becomes rigid. The lava underneath continues to drain until it drains off. The pit starts to collapse a little bit and eventually can give way entirely. And so you end up in this final stage with, at the surface, a little window that's cracked open into a tunnel underground with more solid material at a shallow depth beneath.
Okay, so I was going to say that, lava tubes that I'm familiar with, I've been to one in Hawaii or here in California, and they're all over the world. But they're generally places where you have lava that has come out of a source and then is flowing downhill. It's got to be going from one place to another in order to create a lava tube. So what you're saying here, because if you just have a crater full of lava, the lava is not going anywhere. But you're saying here then that cracks in the tube can then kind of cracks in the crust can on a smaller scale act like a volcano on Earth, and then you have the lava flowing away from the source of this crack, and that's how you end up with a lava tube.
The key thing is if this material becomes more dense, it starts sinking into the solidified
rock.
Exactly. It's as if you were pouring something that was more dense than the water of your bathtub, so something heavier than ice. That's going to sink down, and meanwhile,
yes, and
the
of
water
course,
is going to...
Right. We usually think about the ice in your drinks floats, but water is quite unusual in that quality. That when you solidify ice, it actually floats. Hardly anything does that. So and rock, when you solidify it, it sinks.
It sinks.
And so that's how you end up with this process.
That's how you end up with a pressure, if you will, a hydraulic pressure, to ooze out more lava, and then it flows onto the surface.
Got it.
And it doesn't take much to make it flow because this material is extremely hot. It's extremely, in other words, it has very low viscosity. It's just going to run down any slope that it can find. And for one thing, that's why it winds around. It's because there's not much slope going on there on the floor of the crater.
Okay, so we have lava tubes on the moon, and I wanted to get back and emphasize your fact that permanently shadowed craters are really a very kind of on the edge sort of thing. Like, you have to be way up at the pole so that the crater, the floor of a crater doesn't quite ever get the sun because the sun is so glancing. It's like a whole bunch of things have to come together just right. And yet, if you have lava tubes, you could have enormous volumes
very large
that
volumes.
can be collecting water ice. And it could, I'll be the non-expert who will say this, but it could blow the permanently shadowed crater floors out of the water, so to speak.
So it could.
But we don't know.
We're not saying that it does.
But we don't know how many lava tubes there are.
Right, and at this stage, at this minute, if you wanted to go to a place where you know that it will be ice, I would still go to the polar regions themselves because, well, we know that there's ice there, whereas this is more speculative. But you're absolutely right. This potentially could have, first of all, it's at less high latitude. It could have more easy to access and more massive ice. And let me just show you, this is the best resolution image we have so far of some of these pits along one of these semi-collapsed sections of a lava flow on the floor of Philadelphus crater. So these pits are about 15 to 30 meters across. And the lighting is such that we think that we're looking at this situation here that's shown on the far right. We're near the poles, so sunlight is coming in at a grazing angle. It goes into the skylight area, in other words, this pit, just enough to light up the vertical wall of the pit, which accounts for some of the brightening that you see right there at the very edge of the pit. But it does not enter the cave itself. It does not heat up the rocks inside the cave. The cave stays extremely cold. And when you think about what's happening with this pile of debris here, it is exposed to open space above it with no sunlight hitting on it. It is exactly the situation you have in the permanently shallow regions of the Moon, of the poles.
And if anything, even colder, because you... Well,
potentially colder, although it depends on what...
I was going to say something about cold air, but I stopped myself because there's no air on the Moon.
So to me, these things are, no matter what, whether or not they contain ice, they're still going to be very exciting places to explore. This is perhaps the vision for astronauts returning to the Moon and checking out some of these lava tubes. I think now I should show you what we did in Iceland. So after
yes,
this was reported last year, I felt a need to understand better not just lava tubes, which of course are very well understood and well studied, but under what conditions do you find ice in a lava tube? And how does it occur? Is it just matted on the walls of your lava tube, or is it actually building up masses of ice on the floor? Does the ice flow? Is it just static? Does it form glaciers? In what form and shape does ice occur inside a lava tube? And so I needed a lava tube that was young, so that not a lot of weathering has taken place. I needed a lava tube that had not been open for a very long time. Okay. And I needed a lava tube that was known to have not just a bit of ice, but massive ice. And the best solution I found, and also an affordable one, and it became affordable actually thanks to a seed grant from the Dubai Future Foundation. The lava tube that was our best candidate for this first recon was Haughton-Mars ice cave in Iceland. And so put together a little trip for myself and a student. We invited Astrobotic, which is a space startup that does a lot of things, including lunar landers, but they actually have a drone that carries a LiDAR, which is a laser radar, if you will, that sends a beam around and maps out cavities and the surroundings. So they had a drone that carried this type of instrument, all integrated, and the drone, in fact, is smart enough to sort of build a map of its surroundings as it flies through it. So we invited Astrobotic to join us, and we went to Haughton-Mars lava tube in Iceland. So I'm going to show you this short video of some of the things we see in this ice-rich lava tube, and a couple of tantalizing implications that it has for the Moon.
Okay.
So you can watch this on YouTube. Here we are in Iceland. Yeah, I wanted to pause it.
Oh, yes.
Yeah. I just wanted to show here that, Iceland's capital is down, for those of you who want to know exactly where this is, Iceland's capital is down here. We went to the far northeastern end of Iceland to get to this cave. And it turns out that this cave is in almost the middle of the area that was used by the Apollo astronauts 50 years ago for their field geology training in preparation for going to the Moon. At the time, the cave was not even known yet, and so they never visited it, but my guess is that the next generation of astronauts will return to the Moon. First of all, we'll have a good reason to go back to Iceland, because along with Hawaii and a few other places, it's a very good place to train for the Moon. But on top of that, they'll have the option of checking out lava tubes like this ice cave in preparation for exploring similar caves on the Moon.
You figure Iceland must be chock full of lava tubes.
It has a lot of lava tubes. As it turns out, not many have ice in them because the ground is actually still pretty warm. And then some of these ice-filled lava tubes are pretty old, relatively old.
Okay, so this one was a nice...
Yeah. So I'm just going to keep running this. lots of interesting analogs. So this is the skylight. In other words, the pit that we see in the lava flow and the entrance to this lava tube. I actually mapped out the cave as we went deeper and deeper into it. And I'll just pause here because this is showing you how we were in awe at what we were able to see and map. The ice is not coating the walls uniformly. It's dangling from the ceiling and stalactites, and it builds up mounds in the form of stalagmites of ice. But there are also glaciers. The ice actually flows. There are feeding zones, ablation zones, even a flow front.
Okay, and I need a scale check here.
You need a scale check? Well, this is about the size of half a person. And this drone is about...
okay, but that drone's in the foreground or something, so I wasn't
yeah.
going to trust that as a...
The drone is about 70 centimeters across.
Okay, so that stalagmite
This is about the height of a human being. And you see humans here in a second.
Okay. Oh, okay.
In the scene. But anyway, so we've been reporting the fact that, first of all, that you have microglaciers underground, which have not been really described in the context of any lava tube before. The other thing is, the implication here is that since there is gravity, what is moving the ice is gravity. And the rate at which the ice moves depends on the temperature of the ice. If the ice is very cold, it moves more slowly, but it still moves. If the ice is warmer, the ice flows faster and moves faster.
Yes.
So the expectation here is that if there is ice in lava tubes in massive amounts like this on the Moon or Mars, it too will flow under the effect of gravity, even the weaker gravity of the Moon or the weaker gravity of Mars.
Sure.
And even though it will flow probably at a much slower rate, because it's much colder than on the Earth, it has a lot more time. Some of these lava tubes on the Moon that we're talking about in Haughton-Mars Crater might be close to 1 billion years old. And so we might expect to see not just ice coating walls if there is ice in them, but ice that has somehow moved and accumulated and oozed around inside the cave over time. So this is an analog prediction of what ice might do if it were found inside lava tubes on the Moon and Mars. The other thing is that ice actually is very bad news in terms of the stability of these lava tubes. We're looking at lava tubes on the Moon in particular, but also on Mars. You often hear that they might be used for human settlements. They are like ready-made habitats for you, underground shelters, if you will, to move into. And indeed, they would protect you from dramatic swings in day-night temperature, okay, both on the Moon and on Mars. They would protect you from space radiation, ionizing space radiation from deep space and the sun. They would protect you from the UV of the sun. They would protect you from micrometeoritic bombardment as well. But caves are not benign environments. They're prone to collapse. Sure enough, that's how you even have an entrance to a cave. And when ice is involved, it's even worse news because the ice can fracture the rock. When you have water that's sort of entering a crack or a joint in rocks, when it freezes, it will expand, that will fracture the rocks. And so
as anybody knows who's lived in a cold climate.
We have rock collapses here. This pile here and that pile over there are actually collapses from the rock ceiling.
And looks like the interstate after a hard winter.
And this is actually not a giant pile of rock. This is just a coating of rock because underneath this pile of rock there's clean ice like that.
Mm.
Okay, so it's just rock that is draping now the ice and protecting it. So anyway, we think that if we do encounter ice in caves on the Moon and Mars, we might actually want to look out as well for the fact that they might be prone to ice fracturing. It's called jelly fraction, and therefore collapse.
So we should probably move into the actual mapping so that we will still also have time to go to Canada.
Yeah. So I'm going to show you our drone flights. Astrobotic has this amazing drone. I'll just let this run.
Position, 100% disarmed. You ready for recording?
Now, this is impressive only in particular because first of all, the mapping of the cave will be done within minutes, as you'll see, but also the flying of this drone is done completely without reliance on GPS for the drone to know where it is and where it can go. So we think drones are one way to go here to explore caves on the Moon and Mars. People have talked about rovers, walkers, all kinds of things that have to somehow interact with terrain that you don't know, and also stay in the cave for long periods of time where there's no power from the sun and no comms back to the Earth. So that's actually very challenging. Temperatures are very cold too. So there you go, that's the skylight. Here's the map. In fact, let me pause this, because I think this is probably one of the coolest pictures. Again, this is the skylight seen from a regular drone flying above the entrance of this lava tube. And with the drone, we've mapped out now the underground tunnel, if you will, and we've projected it against this picture. And so this is one direction in which the lava tube continues, and this is the upstream direction where it goes. And this actually gets choked here, so we cannot go further at this point in this direction. This here actually leads to a passage down there. You have to crawl through it, but that's when you have a much longer distance to explore. And we went all the way to the end that we could, which is about 150 meters further in. The diameter of the entrance here is about 20 meters only, and so this is a map of the map of the big chamber 150 meters away from the entrance.
Now there could be little side passages that could be missed if you don't get close enough to them and you miss the fact that...
For sure. And not only that, but some sections of this lava tube are completely filled with ice almost. So you're essentially crawling on ice against the ceiling. Just in a little gap there.
But then lava tubes they tend to be much less branchy than limestone caves.
Right, exactly. So anyway, we were able to map out the geologic features that we recognized with this LiDAR. And the advantage of the LiDAR is it gives you really a very detailed size and volume and shape of your lava tube. So the thinking here is that we might use drones, just like this astrobotic drone, with that kind of technology, to do reconnaissance exploration of lava tubes on the Moon and Mars. And of course, because there's no atmosphere on the Moon or Mars, you're not talking about drones that, like this one, would use propellers or rotors. You're talking about drones that would be thrustered, having mini rocket engines or coal gas engines. And so you go and fly into your cave, not long enough to get too cold. They would fly back out, land on a lander or rover that's carrying them, send the data back to the Earth, recharge their batteries, possibly refuel, warm up, and then go and explore the cave a little further using the map that they've created during their previous passing.
And these would not be copter drones.
Exactly, these would be thruster drones. And the whole idea here is that you have a touchless approach to exploring the lava tube. I mean, you might stir up some dust with your little rocket engines.
Some heat would be added by the rocket engines.
Yeah, although they might be cold gas thrusters, so they don't have to involve combustion.
Okay.
Yeah, so you don't want to disrupt the environment either. But the point here is that even though they might stir up some dust, any approach actually might anyway. But here, at least you'd have a touchless approach, and you could zip through this and map it very quickly. And so we could find out once this technology is mature, what these caves on Mars and on the Moon have to offer. I want to point out just one thing. We know of lava tubes, volcanic lava tubes in this case now on Mars. They are all on the flanks of the giant volcanoes on Mars.
So they have been seen.
They have been seen from orbit. In fact, this video ends with a couple of pictures of these guys. So we just saw the lunar example
There are lava tube caves on the moon.
This is what a drone might do in a lava tube. But then on Mars, on the giant volcanoes of Mars, there are pits that are likely to be lava tube entrances. Okay, and this is of course just a vision for the future. But the point here is that you would
live footage.
These
artist's conception.
These lava tubes on Mars are at relatively high altitude. Okay, so unlike that little helicopter that JPL is now designing for the Mars 2020 rover, which will be flying at relatively low altitude on Mars where the atmosphere is dense enough for you to fly with rotors, these lava tubes are at such high altitude on the flanks of the giant volcanoes of Mars. I mean, they're at 10, 20 kilometers up above the mean level of Mars, that the air is too thin there now to fly anything like a helicopter or a drone.
So again, you need
a propeller drone.
Some kind of a thruster.
You need a thruster system. So this is an example of how exploring the lava tubes of the moon with thruster drones will actually open the door to exploring lava tubes on Mars on the flanks of its giant volcanoes.
Are there likely to be lava tubes at lower latitude or lower altitudes on Mars?
There must be. I mean, there are lava flows galore on Mars. In fact, an interesting paper proposes recently that the entire Noctis Labyrinthus maze is actually a maze of collapsed giant lava tubes. And I actually find that idea very intriguing and interesting.
Okay.
So the answer is yes, there might be some at lower latitude.
But we haven't found them. Okay.
So that's. Should we move on to?
We should definitely move on to Canada.
Part 2. Okay. Do we have any questions about this so far?
So we do have 2 questions that I could read from our content so far. One is, I think about our first brief segment. If risk was no factor, asks Evan, where would you choose to send astronauts or rovers on the moon? What is the dream place to explore?
Wow, the moon has a lot of interesting places that are still untouched. I think the polar regions are high on my list of places I'd like to check out. There's the whole general area called the South Pole Aitken Basin, which is a bit on the far side of the moon, but it's near the South Pole. It's a giant, ancient impact basin on the moon. I, of course, would like to go check out these lava tubes that we talked about, these impact lava tubes near the North Pole of the moon. So, lots of real estate to explore.
Absolutely.
No single one would do it.
Could skylight lava tubes, asks Ron, be used for human structures for habitation? Could they enable subsurface habitation or protection from meteorites of the sun's damaging rays? And you did address this already.
They could. We just don't know enough yet. And so, hence the need to understand them really well on the Earth and then keep doing the same on the moon before we can tell for sure.
Yeah. All right. Let's talk about your research base in Canada.
Yeah, so, and I'm seeing I have a low battery thing. Okay. So, okay. We've been going up to Devon Island in the Arctic for 22 years now. This coming summer will be our 23rd field season. Devon Island is the largest uninhabited island on Earth. And on Devon, of course, the star of the show is this giant meteorite impact crater called Haughton Crater. And I have actually a battery charger in there somewhere. Well, thank you. So Haughton Crater is 20 kilometers across, 23 million years old. This is a view of the crater from 10,000 feet of altitude, looking towards the north. And we've established a permanent base on the northwestern rim of the crater what do you see? It's called the Haughton-Mars Project Research Station, or HMPRS. Thank you, Lee. Okay. So this is a aerial view that we've actually mapped out on our own with a drone of our camp. You can see our base camp that has its star formation here. This is our landing strip. The scale is given here at the lower right. That's 100 meters. This is an ancient coral reef, actually, called the Fortress. It's got pretty beautiful fossils of corals. And this main trail that we used to go from our camp to the helipad or to the airstrip and on into the crater is called NASA Road 1, after this famous road at in Houston that takes you to NASA's Johnson Space Center. Right. So this is another perspective view of our camp with the airstrip here now to the up there. That's the helipad area here. That's the map of it. So the reason why I'm showing this is because we now have the ability with Google Earth to explore this place through Google Earth, and Google became a partner of our project in a big way this past summer, and we just announced this partnership in a news release. And Google has actually created 3 products, so to speak, around our project. One is a guided tour of the camp and of surrounding areas that you can go check out on Google Earth. It's called the Google Earth Guided Tour. Another is a series of street views. So you can now click on our camp or some of the surrounding sites and have a sort of a first-person panoramic view of your surroundings and see it for yourself. So Street View now is available, although it's spotty, on Devon Island. And then the third thing is Google created this video that we'll run at the end after we sign off for people who might not have seen it yet. It's just a 10-minute video made by Google about our project, and it will take you around the sites of this incredible place.
Does it show the spacesuits in the rivers?
Yes, it shows the spacesuits in the river. So this is our base camp. Typical star formation. So this is actually interesting because even though this camp is designed to be effective for the Arctic, we are...
Look who's here.
Oh my goodness.
Someone's here, speaking of the Arctic. It's a good one.
Okay, so I guess it's time for me to introduce...
Time to introduce the polar guard dog.
Thank you, Bill.
Yeah, there
Bill
you
Diamond,
go.
our CEO.
Hey guys.
Good to see you,
Hi
Bill.
everybody. Matt, good to see you. Thanks for coming and talking to Pascal today.
Having a
and
great time.
helping with your insights. Good to see you,
So-
Pascal, and,
Thank you.
and meet Apollo.
Thank you, yes.
Beautiful dog.
So, for the past 20 years, I've been taking my dog, I guess, up to the Arctic in the summer. He helps us as a polar bear guard dog. And the latest dog that I had even last summer, which you see in the Google video, is King Kong, passed away in October.
Yeah, we missed
But
King Kong.
I just...
Oh yeah, that's a
Okay. So I just got
It's a
Apollo.
family show.
I just got Apollo, named after, of course, well, his middle name is Program. And so, just to celebrate
Program, huh?
the 50th anniversary of the Apollo program.
Very
How
nice.
original.
But anyway, Apollo will be our new polar bear guard dog at camp in the Arctic. He doesn't know what he's up against yet.
He hasn't been there yet. So
No.
is he going this year?
Yes.
All right. And will he get the jacket, the official jacket?
He'll
that,
get the jacket. Yep.
King Kong had.
Yep.
Yeah.
Yep.
Very good.
So he's a cattle dog, an Australian cattle dog.
Very nice.
Scarily smart, but anyway, good boy.
Yeah.
All right.
Yeah.
Thank you.
Should I bring him back so you can
Sure.
keep going? All right.
Sure. I'll just keep going for a bit here, and then we're going
Come on.
to wrap up.
Has Apollo or any of your other dogs actually come into close proximity with the polar bear?
No, but you will see them sniff actually the air very intently several times. And of course, the role of the dog, as I explained even in the video, is not to attack a polar bear,
No.
but to
That's not going to go well.
to give us a heads up
To
if there's
alert.
something going on, and so we do run for the guns when we see that the dog is sniffing the air or barking even. Yep.
So you're going to. I'm going to take Apollo back to his base camp for now. But
Okay, thank
you're going to talk about the video and.
Yep.
Yeah.
We'll wrap it up.
Yeah, fantastic. You're going to want to see this video and have an opportunity yourselves to join Pascal and his team, thanks to Google, on Devon Island and experience this absolutely otherworldly landscape. It's beautiful and spectacular and a beautiful video. So
Yeah.
yeah,
I'm trying to get Bill to come up.
I'd like to come up this year if I
next-
can.
next
I'll bring the
summer.
dog.
Okay,
All
there
right,
you
Paul,
go.
come on, let's go.
Yeah, sounds like you're getting along. Actually.
We're doing it. All right, see you guys.
Bye bye.
Thank you, Bill.
You bet. Thanks, Matt.
Thank you, Bill. So yeah, our camp is designed, with the Arctic in mind. It's not emulating a moon base or Mars base. This is how we feel a good functional research base in a polar region, should be configured. And as it turns out, it's actually helping NASA and other space companies think through how you might design, layout functionally.
Sure. And this might be a good place.
A base on the moon.
This might be a good place to bring up the concept of planetary analog, which I've heard you talk about before, right? So Devon Island has some aspects of it that are like Mars, but in other aspects, for example, oxygen that you can breathe, and it's actually, even though it's the high Arctic, it's quite a bit too warm. So you have to think about what are the parts that are serving your analog and what are the parts that are working against your analog. You want to say a little about that?
Yeah, I mean, just like the Apollo astronauts were much better prepared when they went to the moon by having done field work. Mm-hmm. Not just to learn about geology, but to actually practice their exploration skills, to mature their tools, to work out their exploration strategies. It is actually very useful to analyze how we do field work optimally here on Earth, and see what needs to be changed or how it might be transposed to Mars. So you bring up a good point. Analogs are a way to sort of compare what we do here on Earth versus how we might do them on Mars. But the implication is not necessarily that we do these things the same way. It's more that we use the Earth as a reference point. We analyze really very carefully.
Sure.
And then we extrapolate that to the Martian environment or the lunar environment with the modification that it requires. So for example, these habitats here are not connected because they're not pressurized. We can just walk in open air from one building to another. On the moon or Mars, you would want them to be connected and of course fully pressurized. But these are technical details that don't necessarily change the function of these habitats or how each lab is used or what types of instrument it has. So there's a number of things you can still learn that are going to be directly valid for what you would want on the moon or Mars, even though other aspects of the analog are sort of lower in fidelity. So anyway, this is our layout. You can watch this in your own time. I just want to present some of the landscape that we have. This is Devon Island, the ancient lake bed on the floor of Haughton Crater, this large impact crater that is the centerpiece of this site, compared to the terrain that we have on the floor of Rusev Crater on Mars, which is believed or was believed to be an ancient lake bed as well.
Okay.
Here's an example that's more dramatic of a giant, and this is at the same scale actually, a giant canyon on Devon Island, and similar looking winding V-shaped canyons on Mars. These guys are still a big mystery on Mars. In fact, the only theory that has been proposed so far is that they result from water seeping out at a trickle, and so these are valleys that would be growing headwards into the highlands of Mars. But we think that instead they might have formed the same way as this canyon has formed, with the terrain surrounding the canyon seems to be almost untouched by erosion compared to the canyon itself, where you have a deep groove there in the landscape. This canyon here on Devon Island was formed by ice, by streaming ice moving very fast off of an ice cap, which otherwise was extremely cold and just matted against the landscape and not doing much to it elsewhere. So the landscape here is protected by ice. The landscape here is deeply incised by an ice stream, in other words, a glacier coming off of the ice cap. And so we think that this might be what we are looking at here on Mars. These could be ancient glacial valleys with an ancient ice sheet that is now long gone from the highlands around. This is the view that we have of this place that we call Astronaut Canyon. So this is Astronaut Canyon on Devon Island on the left. That's what it looks like when you're standing here. Here. You're standing here looking down to this lake in the foreground and then the longer lake in the distance.
Okay. And then out to the sea?
Out to the sea, yeah, exactly. So this is essentially a fjord that is not filled with seawater. It's a glacial valley.
And it does look U-shaped, like a proper glacial valley.
It looks
should.
somewhat U-shaped, although these are talus slopes, and so a lot of
Yes,
gravity
which
has
means that
changed
it was
the shape.
more U-shaped before the talus.
But originally it was actually V-shaped, and in places where you don't have so much talus accumulation, you actually see the V-shape very well. You see, for example, here, you see the V-shape very well. Here, see? Here as well. It's all V-shaped. Here you have infilling and other things going on that have changed the shape a little bit. So anyway, the site is relevant, of course, for planning Mars exploration, but I'm excited by the fact that since we've heard NASA announce that we're going back to the moon now, to the lunar South Pole, our research site might actually become super relevant again, because at the lunar South Pole, which is shown here, you have a large 20-kilometer impact crater called Shackleton Crater. Inside Shackleton, you have a permanently shadowed region where you might actually have ice, where ice has been reported. And even in the previous plan under the Bush administration to go to the moon, even in the previous plan there were already ideas of having an outpost or a base near the South Pole of the moon on the rim of Shackleton Crater. And at this particular location, not only are you near the South Pole and near the Shackleton Crater, but you are in an area of permanent sunlight. Okay, so as much as the bottom of the pit is permanently shadowed, the crest here of this ridge of the rim of the crater is in permanent sunlight. So as the moon rotates throughout its day, when you're up there on top of that hill, you never see the sun go down.
Indeed.
And so that's permanent solar power. That's very interesting. Anyway, Haughton offers a very similar configuration. It's also 20 kilometers across. The bottom, of course, is not in permanent darkness, but for communications with Earth, for example, you're in a similar situation. The satellite dishes are grazing the ground, and those of you who are into comms, you will know that if you interact with the ground, there are all kinds of interferences that, sort of multiple scattering effects that are issues in communication. So you can learn how to mitigate this by doing similar horizontal-looking satellite comms from our polar site. This is showing Haughton Crater superimposed on Shackleton Crater, with our base camp here, simulating, for example, this outpost that we might have on the rim of Shackleton Crater on the moon. And we are learning, for example, on our project how to plan these long-distance traverses around the crater. You don't want to cut across the permanently shadowed region of the moon where you lose power. You want to stay on the rim and in sunlight. And so you can learn how to plan these road trips, if you will, on the moon with astronaut crews by doing things at Haughton Crater. It gives you a sense of the scale of your operations and what it would take to carry this out.
All right.
So I'm going to wrap up.
So before we go to the 10-minute video, we need to properly sign off
Yeah,
the broadcast.
exactly.
So we will see in the video what you're doing at the site, including testing equipment that astronauts will use on the surface of Mars or possibly the moon.
Yep. I'm sorry. I'm just looking at this because I have somehow my PowerPoint froze, so I'm gonna have to. Yeah, but I'm not seeing it. So we're just having a technical glitch.
Okay.
here.
Well, while we work on that, I
just
still
have to do a restart on this.
Do we have any more questions, Rebecca?
Someone was wondering if methane detected on Mars comes from underground lava tubes containing water.
We don't know yet. So this is very intriguing. What the what the person is referring to is Curiosity, the rover at the surface of Mars, NASA's rover, recently detected some methane in the environment around the rover. And simultaneously, an orbiter from the European Space Agency detected methane from orbit at that location at the same time. So this is a correlated measurement or detection of methane. And as to the origin, we don't know yet. so there are two general categories and implications for methane. One is the fact that methane can be of mineral origin and does not imply biology. But you also have methane that could be of biological origin. And so to know that, you'd have to do things that we're not equipped to do yet on Mars, study isotopes, for example, for the methane. But by understanding better where this methane comes from, so by tracking over time when Curiosity will run into this again, and also whether or not you see it from orbit, we might get a sense of where it's coming from exactly. So at this stage, this minute, it could be coming from surface rocks, or it could be coming from deeper down, we don't know.
Right.
And while you bring your computer back up, I also have our list of locations where people are joining us from. We are joined as usual by viewers from around the world, and some of the places that have signed in are the following: Kurdistan, Kristiansand, Norway, Istanbul, Turkey, Brazil, Prince Edward Island, Canada, Tokyo, Japan, Florida, Louisiana, Lake Havasu City, Arizona, Vancouver, Canada, Almada, Portugal, Lima, Peru, Krakow, Poland, Munich, Germany, Tucson, Arizona, Exmoor in the UK, Little Elm, Texas, South Tyrol, Italy, Provence, France, Germany, Fredericksburg, Virginia, France, Yorkshire, Veneta, Oregon, South Africa, Montreal, Canada, Jensen Beach, Florida, Ohio, Fuerteventura, Canary Islands, Melbourne, Australia, Texas, Pensacola, Florida, Olympia, Washington, Orlando, Florida, Albany, New York, Winnipeg, Manitoba in Canada, Portland, Maine, Stockholm, Sweden, Dunkirk, France, and Norrköping, Sweden. We are very grateful for our global network of supporters, and we couldn't do it without you. Thank you all for being with us today.
Thank you, Matt. So let me launch this real quick. If I can. Yeah, so I've unplugged it because I'm
Okay.
on my,
Okay, good.
my drive here. Okay. Yeah, and if anybody has more questions, I guess feel free to send me an email or ask me through Facebook. It's coming up. So we're just going to launch a 10-minute video that was filmed by Google. Worth pointing out, it was filmed entirely using just their smartphone, the new smartphone, the Pixel 3.
Mm-hmm.
And Google actually is really an interesting partner for our project because of their expertise in information technologies. And so this past summer, the scope of their involvement was limited to helping us sort of with our outreach effort. But we're anticipating more technical work together in the future here.
The video as a kind of end credits. So thank you all for listening. Once more, this is the SETI Institute in Mountain View, California, and we will close with this video of Pascal's base and the new partnership with Google. Thank you, Pascal, for being with us.
Thank you, Matt. It was a lot of fun. Bye, everybody.